Let's now talk about the domain and range of a function. The domain of a function is simply the x values of this function. The domain is the x values, and the range of the function is simply the y values. Let's have an example. For y equal to x squared plus 1, and I have the domain to be equal to -1, 0 with 1. What is the range? Simply to find out the range, I need to substitute each value of the domain. So, when x is equal to -1, y would be -1 squared plus 1, and this would be equal 1 plus 1 to 2. When x is equal to 0, this is 0 squared plus 1. It will be equal to 1, and when x is equal to 1, this will be equal to 1 squared plus 1, and this will be equal to 2. So now, the range would be, the range is y equal to the elements 1 and 2. In this example, I have the domain having the x elements which are -1, 0, and 1, and the range to be y having the elements 1 and 2. Now, always for the range, we look at the y values, and for the domain, we look at the x values. But let's say we have this example. If I tell you that y is equal to the square root of x minus 2, can x take any value in this case? Let's check out. Since I have a square root, and we all know that for order to have a real number, the square root can't be negative. So the value inside this square root simply can't be negative. So now the x minus 2 must be what? Greater than or equal to 0. So the values of x must be greater than or equal to 2. So by this, I can find out my domain for this function. This is the domain. The x values must be equal or greater than 2. Now, let's have another example. Write down the domain and range of the following relation. I have y equals to x squared plus 4. The first step that I have to do, I want to sketch this relation. Sketching does not mean we have to be accurate. First, we draw our axes. This is the x-axis, and we draw our y-axis. After that, I use my graphical display calculator to check for the shape of this curve. I go to graph, and I fill in y1 with x squared plus 4. I have to check for the v window. Is standard -10 with 10, and the y minimum -10 with 10. So I draw my relation. I have it this way. So I'll be drawing the curve. It has this shape. continuous from the right and then continues to the left. I need to check the value of the y-intercept. I go to my calculator, I press Shift and G solve, and I go to y-intercept. I have the y-intercept to be 0 with 4. So the y-intercept is 0 with 4. Now I have to check for the domain and the range of this function. The domain is simply the x values and the range is the y values. So now the domain is, let's check when the x goes to positive infinity or a very large number. Does the function continue? Yes, it does. If the x values goes to negative infinity or a very big number having the negative sign, does the curve continues? Yes, it does. Is there any interruption from negative infinity to infinity? No. So I can say that the x values lie between negative infinity and infinity. So the x values have all the real numbers. So I can say that domain x is x belongs to R, which means that x have all the real numbers. Let's go for the range now. The range we said is the y values. If I go up in the y, having y going to positive infinity, a very large number which is positive, does the curve continue? Yes, it continues. But what if I check when y goes to negative infinity? Does the curve goes down to negative infinity? No, it doesn't. What's the lowest value for y? The lowest value for y is this minimum point, which has the value of 4. So I can understand that the values of y lies between the 4 and the positive infinity. So the range is y is greater than or equal to 4.